titled Preparing Dependencies for Deploying. In this video, we will take a look at managing dependencies. We will also upgrade dependencies and go through our app to make sure it doesn't use duplicate code. Let's talk about managing dependencies. While developing our app, we installed a lot of external libraries using pip. We used virtual envelope to keep Python packages in an isolated place for our app. However, using our own personal hardware, like a laptop, is the best idea. We're going to use a deployment platform from vendors like Heroku, Amazon, DigitalOcean for this. How do we ensure the production environment is the same as development environment? We could simply copy the virtual envelope folder. But it doesn't always work, so you shouldn't rely on this. For example, I can't take my OS X virtual envelope and use it on Linux. The best way is to simply list all the packages with versions in a text file, and then install the exact same versions using pip. We can use pip freeze to list all installed packages in our virtual envelope folder. Let's save the output to requirements.txt, which is a customary name for files with dependencies. Now, for testing purposes, I'm going to deactivate the virtual environment and remove the WFDB envelope directory, and then recreate the environment. Now, when I run the tests in the fresh virtual envelope, you can see them fail since the packages aren't installed. If you install the dependencies by typing pip install -r requirements.txt and run the tests again, they will work. We have successfully recreated our previous virtual environment. What if I need to update versions? I've been working on mastering Flask for a while and haven't upgraded my virtual envelope. It can be a good idea to upgrade package versions every once in a while. So let's see what packages have new versions with this command. Pip list -- outdated -- format equals columns. Okay, we can see that Flask, Flask WTF, Flask Login, Flask WTF, SQL Alchemy, Celery and IPython have newer versions as well as their dependencies. We also had this. Let's update them. Oops, I need to provide -- upgrade flag. Let's run our tests. They work, but we have a bunch of warnings here. Let's fix them. First, we have to replace all imports like flask.ext.login with Flask Login. This is simple, although a bit tedious, since we have to do it for every extension imported in every file. It also seems that Flask cache isn't actively maintained. Let's replace Flask Cache with Flask Caching, which is a fork of Flask Cache. Next, we have to do a couple of renames for Flask WTF. As you can see, we have almost no warnings, except for disabled cache, which is intended, and importing flask.ext.sqlalchemy warning, which I checked. It arises from Flask debug toolbar code. The Flask debug toolbar code was updated in master branch on GitHub, but it looks like there is no fresh release that we can install with pip. We will need the requirements.txt file in the upcoming sections, so let's upgrade it. Great! We're all ready to start deploying our app. So far, we have learned how to use pip to reactivate virtual environments and upgrade package. We've also upgraded our app dependencies and fixed warnings. In the next video, we will deploy our app on a simple virtual private server or VPS. In the previous video, we added final touches to our app to make the deployment process smoother. This is video 2 of section 11. Using a simple VPS. In this video, we will discuss what a VPS is and learn how to deploy our app on a VPS. Let's say I have a laptop with our app running. Why can't I run my app on my laptop? Well, technically I can, assuming it is accessible from the outside. However, it is not convenient since my app will go offline when the power or network connection is down. I would also need to make sure that other software doesn't interfere with my applications running. Also, your home computer isn't necessarily accessible from outside because of network address translation. Okay, but what about running it on a commercial hardware at some company's data center? I could definitely rent a real machine, and many companies offer this type of service. However, modern computers are quite powerful, and many smaller apps don't need that much memory and CPU power. Given that the price for hardware starts from tens of dollars per month, it is somewhat expensive for smaller apps. Fortunately, many companies allow you to rent a VPS. VPS stands for Virtual Private Server. VPS, which is essentially a virtual machine, it has its own operating system, and you have a super user access to it. It is also configured to have networking and has its own IP address. And for many purposes, having VPS is equivalent to having a physical server. Each physical machine usually runs several VPSs, and each VPS gets a share of resources. Memory, CPU, and disk. This means that VPSs are usually cheaper to run than physical servers. We're going to use DigitalOcean.com because they provide inexpensive on-demand VPSs. DigitalOcean has a nice UI that makes creating VPSs a breeze. Let's create a VPS. DigitalOcean uses the term droplet for a VPS, so click on Create a Droplet. You can choose from multiple operating systems and multiple locations for your VPS. I'm going to use Ubuntu on the smallest and cheapest VPS. And let's say my droplet is going to be located in London. Click on Create in the UI and wait for a few seconds. DigitalOcean emails a password, and we can use it to access our server. Let's take this IP address and the password from email message, and use SSH to access our freshly created VPS. If you are running Windows, you have to use PuTTY as your SSH client. But on Mac and Linux, you can simply type SSH root at your IP address. Now we need to change the password. And finally, we have access to our server. We can now start working on actually deploying our app. Let's start by creating a new user, WFDB user, because it's a bad idea to run the code with super user privileges. run add user WFDB user. The next step is to copy our app to the server. The best idea to transfer code from development machine to production is to use some version control system like Git. But for simplicity, I'm going to use SCP for remote copying. I'm also going to remove the virtual environment directory since we have to recreate it anyway. Let's connect again, and let's check if our app is here. Let's start by installing these packages with apt-get, Python 3-pip, virtual envelope, Nginx, Redis server, and Redis tools. Then, let's change our user to WFDB user. Go to Home Directory and then to WFDB directory, and then let's create a virtual environment and install Python packages. One thing I need to do is remove GNU readline from requirements.txt. Since this package is required on OS X, but not Linux. Then, run our familiar pip install -r requirements.txt. We can already launch our app using manage.py script. To make it accessible from the outside world, we need to provide --host_o.o.o.o option to the script. We can now simply run a web server using our familiar manage.py script. Let's test it. It works. However, our app is still running in the debug mode, and if we disconnect from the server, our app will stop running. We need a way to make sure our app is always running, and we need a way to start our app automatically if the server gets rebooted. Additionally, Flask's built-in web server isn't good for production use, so we need to use a suitable web server. DigitalOcean has great tutorials for deploying our app. I recommend checking them out. I'm going to do pretty much what I described in this tutorial. How to serve Flask applications with Gunicorn and Nginx on Ubuntu 16.04. Gunicorn will run our Python code, and Nginx will proxy requests for gUnicorn, since running gUnicorn alone isn't secure, because gUnicorn alone is susceptible to denial of service attacks. Example, slow loris. Let's start by installing gUnicorn with pip. Then, we need to tell gUnicorn where to get our app. To do this, create a new file called application.py. In this file, import create_app and create_app using prod config. I also forgot to add Celery variables to prod config. Let's fix this real quick. Run gUnicorn using this command. We can see that our app is running. Now we need to create systemd units. Systemd is an init system that is used by Ubuntu 16.04. We're going to create two unit files to tell systemd how to run our web service and Celery processes. There is a good guide on DigitalOcean for creating unit files. Create a file in etc. systemd system named wfdb.service. Systemd unit files consist of several sections. The first section is unit, where we add description and dependencies. We need network, and we need readies for Celery. The service section describes how to run our app. We provide a user account to run our app under. Then we provide environment variable path, which we set to bin directory inside our virtual environment. Then we provide the actual command to run our app. And finally, we tell systemd to run our app when our VPS is up and running. Then we need to create a second unit file, wfdb_celery.service. It is going to look pretty much the same. As you can see, the main difference is exec start command. Then, run the following commands to start our services. System control start wfdb. System control start wfdb Celery. Then let's tell systemd to run the services at boot time. System control enable wfdb. System control enable wfdb Celery. Finally, let's create nginx config. Create a new file named wfdb in etc. nginx sites available with the following content. Make sure that the server name is the IP address of the VSP, or its domain name if you have one. To enable this site, create a symbolic link in the Sites Enabled directory. Then, tell systemd to restart Nginx. Now, if we go in browser to our VPS, we can see our app running in production. Okay, we learned a lot in this video. First, we learned about VPSs. Then we created a VPS on DigitalOcean and configured it to run our... Hello everyone and welcome back using Heroku. In this video, we will cover what is Heroku and how to deploy your app to Heroku. Heroku is another platform as a service PaaS provides that this video will cover. Heroku is a PaaS that aims to be easy to use for web developers by hooking into already existing tools and not requiring any large changes in the app. Before we begin, you will need a Heroku account to follow along. If you just wish to experiment, there is a free plan. Before we deploy our code, we need to make some modifications to our project to provide the files and configurations that Heroku needs. The first step in getting our app on Heroku is to create a file called procfile, which Heroku uses to determine how to run your app. In procfile, we only need 2 lines, one for web app and one for Celery. We are already familiar with those commands from previous videos. Make sure the name of the WSGI object in application.py matches the provided name here. Then we need a small file called runtime.txt, which tells Heroku which version of the Python interpreter we're using. Next, create a new application. Next, we need to provision Postgres database and Redis. Heroku UI makes this really simple. Click on Resources. Let's add Heroku Redis. And let's add Heroku Postgres. There are other add-ons you can add to your application. To install it, use this command. Then run Heroku. You can see the full list of different plugins here. After we've provisioned Redis and Postgres plugins, we can see URL on the settings page. The next step is to install Heroku's command line tools, as this is the simplest way to directly deploy your code to their servers. There are other options, like using Dropbox together with Heroku Web UI, but the command line tools allow you to have an easier control on your app. They can be downloaded from the URL on the screen. To test and debug your app locally, you'll also need to get config variables from Heroku. While we could copy and paste those variables, it is much better to use Heroku config plugin. To install it, use this command. Then run Heroku config, -awfdb. We can see our variables in .env file. Next, populate the Postgres database using the prepared dump wfdb.sql using Heroku pg:\psql command. You can ignore "these roles don't exist" errors. Finally, we need to update our create_app function to get settings from environment variables set by Heroku. Then call the function after from_object call. After you have downloaded the tools and made adjustments to the code, variables that we set from run the following command, then call the function to log into your Heroku account and save your credentials. Then, in config.py, remove variables that we set from file. And make sure it uses cache_type simple. Then change celery_runner.py to use prod config. Then make sure you have Psycho-Page 2 and Gunicorn installed. And update your requirements.txt if necessary. Before you deploy to Heroku, the command form start will simulate the Heroku server so you can test if your app runs before you deploy. The way that you deploy with Heroku is by pushing to a new remote Git branch. Heroku will automatically detect that you have pushed new code, and it will restart your server. To create this remote branch, run the following command. I don't get a Git repository at this directory, so I'm going to create one. But you may use an existing Git repository. In fact, it is a great approach to start using Git from the very beginning of development. To create this remote branch, run the following command. Use this git command to push to the Heroku branch. If everything went well, you will now have our app running on Heroku, which can be seen by running Heroku open. And we even have a nice domain name here. That's all for Heroku. So let's review what we've covered. We modified our code slightly and installed some new tools and got our code running on the servers. Let's wrap up things in the last video of this course. Join me. Hello everyone and welcome back. I hope you enjoyed the video series. In this video, I would like to outline what improvements can be made to our WFDB app so you can test your acquired skills. One of the improvements would be using Flask Migrate for database migrations. For example, adding or removing tables or columns. While we could use raw SQL queries, this isn't the best option. It is much better to use a dedicated Flask extension that makes managing migrations much easier because it will automatically detect changes in your SQL Alchemy models. It also has nice integration with Flask script. One of the changes we could make is adding email column to our user. Another related improvement we could make is allowing logging in by providing emails as well as changing our registration form to include email field. Then you could change our digest sending code to send the digest to every user. A good Flask extension that you could use is Flask User. It makes things like emails, password resets, and password changes easier. Sending emails from your server is difficult because you have to properly configure your server, so other servers would accept your emails and not mark them as spam. It is much easier to use a service like Mailgun, MailChimp, or SendGrid. There are free plans which are great for smaller apps. Perhaps you could update our digest sending code to use one of these services. And if you are using Heroku, these services are available as plugins. I haven't used version control systems much throughout the course because this isn't the course on VCS. However, using VCS is really good practice, so I encourage you to use it. For example, Git. If you aren't familiar with Git, there are a lot of resources available. This is, of course, free official documentation. And Pact Publishing has a lot of courses on Git to offer. If you are planning on using only Heroku, a recommended pattern is putting all of your settings to environment variables. So you can move all settings, like debug equals false or secret_key to the settings. If you plan to use Heroku exclusively, it would be a good idea to get rid of your configuration objects entirely. As a reminder, you can synchronize your .env local file for Foreman and remote Heroku settings by using Heroku Tool Belt. The file uploading part will not work properly on AWS Elastic Beanstalk or Heroku. It may seem to work, but it will stop working properly when our app is scaled to multiple instances or when our app is moved to another machine. Since we have no way to control when this happens, it is better to disable file uploading altogether. We have created models and tables for tags. Our tags aren't clickable. It's a good idea to add filtering by tags. While having simple cache options may be enough for some cases, it is often better to use Redis. Flask caching allows us to use Redis as backend for caching, and it is actually pretty simple. That's all for this video and the course. I hope you have enjoyed the course as much as I have putting it together for you. Keep learning.